In this video, we're going to talk about calculations and frictions. Now, in our previous video, we talked about friction and forces. We defined and gave an examples and gave conditions and the laws of frictions. So here, if you've not watched the video, do well to go to that video so you can understand the foundations and the fundamentals. So here we are moving on calculations. Here this question says a stationary mass of 2 kg resting on a smooth floor, coefficient of static friction 0.2, is acted upon by a horizontal force of 40 Newton. If the mass experiences a counter force of 12 Newton, what is the acceleration of the mass? Acceleration due to gravity 10 meters per second squared. Now, one thing we need to understand is that the first thing we can do to solve this question is to bring out the parameters given to us here. It said a stationary mass of 2 kg. So here, let's say solution. Mass M is 2 kg. Resting on a smooth floor, mu 0.2. is acted upon by a horizontal force, so force is 40 Newton. If the mass experiencing a counter means opposing force, so FO is 12 Newton. What is the acceleration? A. We need to remember the general formula that we gave, that FA cos theta minus FO plus FR, opposing force, plus frictional force, two of them are the opposing forces, is equal to mass times acceleration. This is the system of forces that is functioning. The applied force times the angle in which it is inclined minus the opposing force, that's what gives us mass times acceleration. Force is equal to mass times acceleration. Now, since the force is horizontal, you need to know that since the force is horizontal, it doesn't have any inclination. Theta is 0, and cos 0 equals 1. So since cos 0 is 1, we can now have that applied force. If we can recall that FR, friction, is giving us mu times normal reaction. Now, they give us FR is equal to mu times this. Now, one thing we need to understand is that they gave us mu, but they did not give us the normal reaction. We know already that normal reaction is giving us mg cos theta. So for us to get that, we say it is equal to the mass is 2 kg times acceleration due to gravity is 10 times cos theta, that is cos 0. What we will get is 20 Newton, normal reaction. Therefore, our frictional force equal to mu, this is 0.2 times this is now 20. Frictional force is 0.2 times mu is now 20, so 20. If we multiply that, we will get 4 Newton. We've gotten our frictional force as well. So we go back to that formula that says that FA minus FO plus FR is equal to MA. Did they give us FA? Yes, 40 Newton is minus bracket. Did they give us opposing force? Yes, counter. They called it counter, which is opposing, which is 12 Newton plus the frictional force is 4 Newton that we've calculated here, is equal to mass 2 times A, that's 2A. If you resolve, you notice that on this other side, you are going to get 24 is equal to 2A. Therefore, A is equal to 24 over 2, which is A is equal to 24 over 2, which is 12, 2 here too, that's 12 meters per second squared. So if you resolve this side, you get 24, which is equal to 2A. So 24 is equal to 2A. Make A subject of the formula, you have 24 over A. That's this. So this is the acceleration that mass will encounter. So we have a second question that says, a body of mass 5 kg resting on a rough floor. Coefficient of static friction is 0.12. Is acted upon by a force of 30 Newton, inclined at 60 degrees to the horizontal. What is the acceleration of that body? Okay, for us to solve this, we can make a little sketch. If this is that mass, 5 kg, and inclined is the force of 30 Newton at an angle of 60 degrees. Once we have gotten something like this, it gives us a picture. Remember our formula that Fa cos theta minus opposing force plus friction, now force equal to Ma. Now, let's get through the question. A body of mass 5 kg, it means that the mass is 5 kg. On a floor, so mu is 0.12, is acted upon by a force, so F, that's applied force, is 30 Newton, okay, at an angle of, that's angle theta is equal to 60 degrees. Now remember that they want us to now find acceleration. Remember that frictional force is giving us mu n r, and here the same thing, we need to find our normal reaction. We were not given the normal reaction, we were given mu for us to find the frictional force, so we can add it here. Now for us to get the mu, remember mu said normal reaction, sorry, is equal to mg cos theta, and that is our m is 5 kg times g is 10 times cos 0, because the normal reaction, since it's on a horizontal, the normal reaction will go to this way, so cos 0. Now normal reaction, if you calculate, will give you 50 Newton, because cos 0 is 1, so 5 times 10 is 50. Now having gotten that, we can now say that friction, the frictional force, is 0.12, because that is mu 12 times 50, which will give you 6 Newton. Yes, 6 Newton. Now having gotten that, we can now use our formula that says Fa cos theta minus into Fr, since there is no opposing force, is equal to Ma. So Fa is 30 times cos 60, that's the inclined, minus the frictional force is 6, is equal to mass is 5 times acceleration we're looking for, A. So if we resolve this side, we're going to get 9 is equal to 5A. Therefore our acceleration A is giving us 9 over 5, or we can say it is 1.8 meters per second squared.